Thought 413 starts with a low, steady beat under the voice. You hear the hum of a ramp, the clank of ground crews, the distant roar of an engine spooling up. Cut to a slow push-in on the jet. Angular.com. Dangerous. Today we re-walking through what it takes to prepare America's most aggressive stealth fighters for combat action. The machines, the people, and the invisible systems that make them deadly and survivable in modern air warfare. You don't need to be a pilot to appreciate the choreography. On the Flightline, it looks almost ritualistic. Pilots and maintainers moving with purpose, each action tuned to safety and speed. But behind that choreography are layers of design choices and tech. Radar-absorbent skins baked into the airframe to reduce maintenance time, modular components so the jet can be turned around faster and integrated. Logistics systems that track the health of parts and schedule maintenance before things break. These design decisions aren't just about cutting costs. They directly boost how many aircraft are available when a crisis hits. Wikipedia, +1. A big part of preparing a stealth fighter isn't just hardware. It's mission data! Before an aircraft leaves the ramp, it's connected to its logistics and mission planning backbone. For the F-35 family, this means feeding diagnostics, parts, status, and mission loads into a centralized system that helps planners and maintainers coordinate sorties and supplies. That system has evolved over time into a cloud-driven architecture designed to increase aircraft availability and streamline maintenance planning. Think of it as the jet's medical record and flight schedule combined. It's what lets crews know which aircraft are healthy and which need attention. And it shortens the time between landing and relaunch. Government Accountability Office, +1 on the ground. Stealth care is a literal specialty. The radar-absorbent material on stealth jets isn't just paint. It's an engineered skin that requires careful handling. Modern designs aim to bake RAM into the skin or use tougher coatings so that routine inspections don't slow operations. That change lowers the maintenance burden compared to older stealth aircraft. But it doesn't eliminate the need for close, methodical inspections. Ground crews check for dents, panel gaps, and anything that could create a radar reflection. Those inspections are methodical but efficient. The goal is to preserve stealth while getting the jet back into the fight as quickly as possible. Wikipedia, walk around the aircraft and you'll see people in different roles. Weapons loaders move like clockwork, but they're governed by strict procedures. Safety first. Always. Avionics tech strap on diagnostic boxers, plug in the maintenance ports, and pull down the latest software and mission packages. Fuel crews coordinate with ordnance teams to ensure aircraft weight and balance are managed for the assigned mission. Life support technicians check the ejection seat, the oxygen system, and the pilot's survival gear. Each of these tasks is a specialty, practiced until it becomes muscle memory. The result is not chaos, but a highly coordinated flow that turns a complex machine into a ready tool. For the pilot, preparation starts long before flight. Mission briefings, stitched together intelligence, weather, airspace control, threat analysis, and the desired effects of the sortie. The pilot's helmet and cockpit are loaded with mission-specific data, navigation routes, threat locations, target coordinates, and timing. For fighters like the F-35, the helmet is more than a visor. It is a full information system that overlays sensor feeds infrared imagery and targeting cues directly into the pilot's field of view, allowing the pilot to synthesize a huge amount of information instantly. Every piece of data loaded before takeoff helps reduce uncertainty in the sky. U.S. Air Force +1. Sensors and networks are what make a modern stealth fighter more than a fast, quiet airplane. Distributed sensor suites, infrared cameras, radar warning receivers, targeting pods, and more. Gather a tidal wave of data. Much of that is fused onboard, so the pilot sees a single, coherent picture instead of dozens of conflicting streams. That sensor fusion is what turns stealth into an offensive advantage. The jet can detect threats early, cue weapons precisely, and share its picture with other assets so the whole force benefits. Preparing the fighter means ensuring those sensors are calibrated, the data links are secure and healthy, and that the mission data packages are current. Lockheed Martin +1 weapons loading is one of the most visible and tightly controlled parts of pre-mission prep. But it's also constrained by law, oversight, and strict safety rules. Weapons crews follow certified procedures to physically load armaments and to verify fusing, arming circuits, and safety interlocks, all under the watchful eyes of ordnance supervisors. Modern stealth fighters can carry weapons both internally and externally. Internal carriage preserves stealth. External stations increase payload at the cost of a larger signature. Mission planners make deliberate trade-offs about what the aircraft will carry, balancing survivability with the force needed to accomplish objectives. That discussion between mission planners, pilots, and commanders is a core part of pre-flight preparation. Avionics and software updates are quiet but mission-critical work. Before a combat sortie, technicians verify the aircraft's software build, confirm sensor calibrations, and run health reports. These checks catch degraded components, intermittencies, or software glitches that could compromise a mission. The logistics system, the aircraft's nervous system for tracking faults and spares, then prioritizes repairs and parts across the fleet so the most critical assets stay mission capable. The interplay between software health and physical maintenance is one of the big changes in modern air power. Software problems can ground an aircraft as surely as a cracked turbine. Blading crews have adapted new processes to manage that reality. Government Accountability Office +1. Human factors matter as much as machinery. Pilots run through physiological checks, ensure their flight suits and helmets are fitted, and undergo last-minute rehearsals of the mission timeline. The F-35 helmet, for example, receives custom fitting sessions. It is tuned to the pilot S-head and to the jet S sensors, so the imagery lines up exactly with the pilot S line of sight. That fitting is critical. A misaligned helmet display can reduce situational awareness and increase risk during high-demand phases of flight. Training units treat pilot prepping as both technical and psychological readiness. Knowing the mission, the aircraft, the escape plans, and how the jet's capabilities mesh with the rest of the force. U.S. Air Force +1. Communications and electromagnetic preparedness get special attention. Stealth doesn't make a jet invisible forever. It changes how and when the jet wants to be seen. Secure data links, encrypted radios, and mission control plans are established so the aircraft can share data without betraying position unnecessarily. Electronic warfare suites are tested to ensure they can sense and, if authorized, counter hostile radars. These systems are tested in maintenance and also rehearsed in the simulator, so pilots trust the indications in combat. Preparation is as much about choosing when to speak as it is about what to say. Simulators and mission rehearsal systems multiply readiness. Pilots rehearse mission profiles and contingencies in high-fidelity simulators that mirror the cockpit, sensors, and even the helmet displays. These rehearsals let flight crews practice tactics, timing, and coordination without burning flight hours or risking equipment. Touching virtual targets in a simulated environment tightens the human-machine loop so that when the real thing happens, reactions are automatic and precise. There's also the intangible layer of force orchestration, assigning roles within a strike package. Deconflicting airspace, lining up tanker tracks, suppression of enemy air defenses, and establishment of commandant control links. Preparing a stealth fighter for combat is rarely a solo activity. It's about how that fighter plugs into a networked plan where air, sea, and ground assets play complementary roles. The jet's stealth lets it enter contested environments earlier and with less warning. But success depends on the choreography between platforms and the intelligence that drove mission planning. What about sustainment in a contested environment? That brings logistics to the fore. When operations are dispersed, bases may not have all the spares, tools, or secure networks that a home station provides. That's where mobile maintenance kits, forward deployed support teams, and robust supply chains come in. Modern logistics systems aim to be flexible. They can route spare parts where they're needed, keep sensitive software updates secure, and allow maintainers to keep jets flying even when infrastructure is limited. This modular, deployable approach is as important to combat readiness as the aircraft itself. Lockheed Martin +1. Finally, there's a cultural element. An organizational insistence on checklists, accountability, and continuous learning. After every mission, there is a debrief where crews review what went right and what didn't. Flight data, sensor logs, and maintenance reports are analyzed and fed back into training and sustainment decisions. That loop: fly, learn, fix, repeat, is why a well-maintained fleet can achieve high sortie rates under pressure. Preparing a stealth fighter for combat action is therefore not a single checklist item. It's a multidisciplinary, distributed effort that blends mechanical care, software hygiene, human readiness, mission planning, and supply chain resilience. The jet on the ramp is the visible tip of a massive iceberg of systems and people that keep it lethal and alive. When you see one launch, remember, there are dozens of invisible preparations that made that moment possible. From specialized coatings and helmet fittings to cloud-driven logistics and rehearsed tactics.